So what is Molecule and why should you use it? At a high level, Molecule is just a tool that automates Ansible role development and testing. But the reason that I like it so much is because of the speed with which I'm able to develop Ansible roles using it. If I jump over to the repo, you can see it's maintained by Red Hat Ansible and has nearly 2,000 stars. So it's a fairly mature project. What it's going to allow you to do is automate all the steps along the way of developing your role. So you can use it to run linters, create instances, execute a playbook, and then also test those instances with an automated testing tool. It also excels for executing any of those steps along the way. So for instance, in a role development workflow, what you'd like to do is basically create your instances and then execute a playbook multiple times. And Molecule is going to excel in that workflow too. In this tutorial, we're using the Docker driver for the instances, and it's worth pointing out that even if you're developing roles for bare metal or cloud infrastructure, using the Docker driver is still suggested because you can get fairly close to a setup that matches cloud or bare metal infrastructure, but what Docker is going to allow you to do is tear down and spin up instances really, really quickly. All right, let's jump in, see how to install Molecule, and see how you can use it to develop and test a role. First thing I'll do is show you how to prepare your system to develop Ansible roles with Molecule and Docker. You will need Docker installed. I'm running Docker Desktop for Mac version 2.0, and however you've got Docker installed on your system is totally fine as long as it's running and working. You can usually check that by running docker info, and if all of this diagnostic information prints successfully, you should be ready to go. I've already got Ansible installed, and I presume that you do as well. If I run Ansible -- version, you can see that I'm running Ansible 2.7.7. If you've got Ansible and Docker already installed on your system, all you need to do to install Molecule is run pip install Molecule. I'm also going to install the Docker package, which is the Docker library for Python. Molecule is installed successfully, and I can check that by running Molecule -- version. That's going to show that I have Molecule version 2.19.0. So I'm ready to go with Molecule. What I'll do is I'll initialize a new role. The way to do that is by running Molecule init role, and you can set the -- role name. I'll set this to Ansible role Redis. And what I'll also do is set the driver name explicitly to Docker. What that command is going to do is initialize a new directory full of Ansible and Molecule boilerplate. I'm going to open this up in VS Code by running code Ansible role Redis, and we'll jump in and take a look what Molecule has generated for us. So what Molecule init has done is initialize an empty role. If we take a look at this main tasks file in here, you can see it's totally empty. We've got an empty vars file as well. The most important thing that Molecule init has done is initialize this Molecule directory with some boilerplate Molecule configuration. If you take a look at this molecule.yaml, this is going to tell Molecule how you'd like this role to be tested. So the important keys in here are the driver key, which says that we want our instances to come from Docker. Next, we've got the platforms one, which is basically telling Molecule what instances you'd like to launch to test your particular role. At the moment, we have a single item in here called instance, and that's going to run the official CentOS 7 image from Docker Hub. The next thing that it's going to do is configure the provisioner, and the provisioner is going to run this playbook.yaml in here against all of the instances that get launched. You can see there's a single play called Converge, and all that's going to do is apply this Ansible role Redis to the instances. Next, the important thing I think here finally is this verifier key, which is using a test infra item. And what test infra is a Python package that allows you to test infrastructure with a Python script. So this is the boilerplate test_default.py, which is going to be applied to our hosts after the playbook has been applied. There's a single test in here called test hosts file, and the boilerplate in there is just going to find an etc hosts file on the host, assert that it exists, and assert that the user and group of that file is root. So that's basically the boilerplate. With that default configuration, you can actually run molecule.test straight away. Let's go ahead and see how Molecule actually works by running Molecule test on our empty role. What I'm going to do is bring up the terminal and run Molecule test. The first thing Molecule test is going to print out is this test matrix, and that's going to list all of the actions that Molecule is going to take to test our role. Instead of going through that, I'll just go through the output here from Molecule to explain what Molecule is doing at each step along the way. The first action here is lint, and what that's doing is executing YAML lint, Flake8, and Ansible lint on the various files in your role to make sure that the syntax is all correct. The next thing it's going to do is run this destroy action, and what that's going to do is destroy any leftover instances from previous runs to make sure that we're starting from a blank slate. The next action is dependency, and what that would do is install any dependencies from Ansible Galaxy if you had a requirements file, but since there's no requirements file by default, it's going to skip that step. The next action there is syntax, and what that's going to do is run a syntax check on the playbook to make sure that Ansible can execute it. The next action is a really important one, and that's the create action. And what the create action is going to do is spin up the instances on which to test our role. Since we're using the Docker driver up here, and we've got these platforms down here, what it's going to do is create Docker images using this dockerfile.j2. You can see that all it's doing is taking a base image here and then running a command here to install some Python dependencies and things like that to make sure that Ansible can actually run on the instance. And we've only got a single image in there, so a single instance of CentOS 7. What it'll do is create a Docker file for CentOS 7, make sure that all of the dependencies to run Ansible on that image are there, and then create an instance from that image. The next thing we've got down here is this prepare action. So we don't have a prepare playbook configured, so it's just going to skip that. The next action is probably the most important one, and that's converge. What the converge action is going to do is run this playbook against all of the instances that got launched. And this playbook is just going to apply the role. It's an empty role, so all we're going to get is this gathering facts, task succeeding, and that's it. The next action there is idempotence, and what that's going to do is make sure that if we run this playbook again, that nothing changes. So if we run the same playbook twice without changing anything in between, there should be no changes. The next action there is side effect, so we don't have a side effect playbook, so it's going to skip that. Next one is verify. Verify is going to run that test_default.py against all of the instances. It's going to use test infra and pytest to execute that. And you can see here that we have one test passed in 14.5 seconds. Finally, it's going to run this destroy action. And the destroy action is going to remove any of those instances that got spun up during the create action to leave us with a blank slate. So that's the molecule test command, and that's everything that molecule can do. This isn't really the right workflow for developing a role, but when you're testing a role, once everything's done, this is the way to go. In the next video, I'll show you how you can use molecule in a development workflow. So when you're developing roles, what's really important is to get quick feedback on your changes. Molecule test is not going to be the best command to run in that case because it runs a whole bunch of tests that you don't really need, and it's going to destroy your infrastructure every single time. The better command when you're in a development workflow is to run molecule converge. What molecule converge is going to do is skip most of the items in that test matrix. And you can see down here that the test matrix for molecule converge is dependency, create, prepare, and converge. Really what it's doing is it's creating your instances and applying your role. That's it. If we look down at the output here, you can see that it's creating our Docker instances, and then it's going to apply that converge playbook straight away. So the other really cool thing about converge is that if I run it again, after having run it once the first time, because it doesn't destroy your instances after it's finished running, it's just going to skip the create task on the second time you run it, and it's going to be really, really fast. So you can see that it's jumped straight down to applying the converge playbook. Let's see how quickly we can get feedback on our changes. If I go over to this main tasks file and I paste in this debug task, what I'm going to do is print the Ansible distribution and the distribution version and just have some output. What I'll do is I'll run molecule converge again, and we can see here that it's skipped create. It's gone straight down to applying the converge playbook, and we can see here that very, very quickly it's done, and I can get feedback on that new role. So that's perfect for a development workflow. You run molecule converge, make some changes, run molecule converge again. If you ever need to start from fresh instances, all you need to do is to run molecule destroy. And what molecule destroy is going to do is just destroy all of your instances. So the next time that you run molecule converge, it's going to create fresh new instances and apply your role to that. One of the most powerful things about Molecule is the ability to test your role against multiple other platforms. At the moment, we just have a single CentOS 7 platform that I've renamed to CentOS 7. And if I want to test this role against multiple other platforms, let's say Ubuntu and Debian, all I need to do is add some items to this list. I'll paste in some other items. So I've got Ubuntu 18.04 here and Debian 9, and those are both just using the official base images from Docker Hub. If I run Molecule Converge now, what you'll see is that Molecule will automatically detect this change, spin up new instances based on those platforms, and apply the Ansible role to that. So it's going to take a little while for a Molecule to finish building those images and spinning up the containers. But once that's done, we'll come back and we'll see what happens when we apply the Converge playbook. So the Converge playbook is being applied now after the images have been created. And what should happen is that our playbook is run against all three instances. As you can see down here, we've got output from Ubuntu 18.04, CentOS 7, and Debian 9. and our debug task in our main tasks file is being run on all of those instances. So that just shows how easy it is to add additional platforms to Molecule to test on. So now that we've seen how we can use Molecule in a development workflow, let's go ahead and actually develop this Redis role. What I'm going to do is replace this debug task with some blocks of code that I've prepared earlier. In this first block, what I've got here is install Redis on Red Hat-based distros. And inside that block, I've got two tasks that are going to ensure that the EPL repo is installed and then ensure that Redis is installed. And that block is only going to run when the Ansible OS family is Red Hat. The next one I'm going to do is install Redis on Debian-based distros, and inside there we have two items in the block again. Ensure Redis is installed on Debian, and then we're going to disable the IPv6 binding, which is sometimes on Debian-based distros. And that's only going to be run when the Ansible OS family is Debian. So what I'm going to do now is run Molecule Converge, and that's going to use the instances that we're left with from our previous run of Converge, and it's going to apply our new changes directly to all those instances. That's going to take a while to run, so I'll come back when it's finished and we can go over the output. So that role's finished running against all the instances now, and as you can see, the blocks are operating exactly as we expect. We're getting some tasks running only on the CentOS 7 machine, and then some other tasks that are running only on the Debian instances. So we've got our ensure EPL repo is installed, which is only running on CentOS, and then ensure Redis is installed on Red Hat, also only running on CentOS. Our ensure Redis is installed on Debian is running on Debian 9 and Ubuntu 18.04. And then finally, the disable IPv6 binding is only going to change on Ubuntu 18.04, but it's also been run on Debian 9. And you can see that with Molecule Converge, all we've had to do is make some changes to our role and run it against all of our instances, and immediately we get feedback. If we ever wanted to run this against fresh instances, all we need to do is run Molecule Destroy, and we could start again from scratch. So let's write our first test with Molecule. What I want to do is, now that Redis is installed in our systems, why not confirm that with a test? What I'm going to do is replace this boilerplate test hosts file test with some code that I've prepared earlier. What I've got is a function here called test Redis installed, and what we've got is host as the first argument. What that function is going to do is get the Redis package name using this underscore get Redis package name function that I've created down here. So any functions that are prefixed with an underscore are not going to be interpreted as a test by test infra. What this is going to do is it's going to take the host distribution and return the name of the package on that particular system. So you can see on Ubuntu, Debian, and CentOS, we have different names depending on the distribution. So the way that we're calling that up in the function is by using this host systeminfo.distribution, and this host variable is going to be populated by test infra. The system info is going to contain various information about the system, and distribution is one of those keys. The next thing that we're going to do is find the Redis package, and that's going to happen with host.package, and then we're going to use that Redis package name. So for instance, on the Ubuntu instance, this is going to get host.package with Redis-server. Finally, what we're going to do is assert that the Redis package is installed. The way that we would run this without running Molecule test all over again, because I don't want it to destroy the instances, reapply Converge, we've just applied Converge and I just want to run this test. The way that I would do that is with Molecule verify. All that's going to do is run that single item in that test matrix, which is verify. If you remember from the Molecule test video at the beginning, what it's going to do is just apply that test file to all of the instances. You can see here that it's collected 3 items, 1 item for each one of our instances, and it's going to run that test against all of them. This usually takes around 30 seconds to run. It is a little bit slow, but it's definitely faster than actually going onto each one of these instances manually and checking that the Redis package is installed. So that's finished running now, and what you can see is that we've got 3 pass tests in 33 seconds. Again, not the fastest, but much quicker than going on and doing it manually. So this is how we write tests for Molecule using test infra. The next thing I'd like this Redis role to be able to do is to manage that service. So what I want to do is add a new task that's going to make sure that the Redis service is started and that it's also enabled so that it restarts on boot. What I'm going to do is paste another task down here called ensure Redis service is started and enabled. That's just going to use the Ansible service module to make sure that Redis is started and that enabled is set to true. If I run Molecule Converge now against all of our instances, what it's going to do is just ensure that that last task is done. I'm just going to skip through this and I'll come back once it's down to that last task. So that playbook's finished running, and I can see that it's failed against all of our hosts. If I go back to molecule.yaml, I'll explain why. The reason is that these official base images for CentOS, Ubuntu, and Debian are not service enabled. They're not running initd or systemd, which would enable us to manage services on there. What we need are some service-enabled Docker images. Luckily, Jeff Geerling guy on Docker Hub and GitHub, maintains an awesome set of Docker, Ubuntu, Ansible, Docker, Debian, Ansible images that are service-enabled and would allow us to actually manage services on there. These are designed specifically for Ansible testing, so this is exactly what we need. What I'm going to do is replace these official base images with Jeff Geerling's images and explain what this configuration does. So if I look at the CentOS 7 item, what I've done is I've replaced this CentOS base image with Jeff Geerling's Docker CentOS 7 Ansible image. What I've added is these 3 configuration items, command, volumes, and privileged, which are all required to allow services to run on that particular container. This is not recommended for production, but since we're only doing Ansible testing, I think it's totally fine. And this pre-built image basically instructs Molecule to ignore this dockerfile.j2 and just pull this image directly from Docker Hub. So the way that we're going to run this is by first running Molecule destroy and then applying it with Molecule converge. The only thing we need to do to apply our changes to platforms is run a quick Molecule destroy to remove any of the instances based on the official base images. So the next time that we run Molecule converge, it's going to build new instances from Jeff Geerling's images, and we're going to be able to manage services on them. So Molecule destroy is finished running. What I'll do now is run Molecule converge, and that's going to take a little bit of time to run because it's going to need to build new containers from those images. So I'll come back when that's done. So that playbook's finished running now, and you can see now that we've switched to Jeff Geerling's service-enabled Docker images from the official base images, this ensure Redis service is started and enabled task is successful on all of our instances. So now that we've got services enabled, why don't we add an additional test to ensure that the service is started and that it's enabled? What I'm going to do is paste some code I've prepared earlier. This function down here that I've added is called test Redis service started enabled. And what that's going to do is get the Redis service name using our _ get Redis package name that we used previously. It's going to get the Redis service using host.service based on the Redis service name. And then finally, it's going to assert that the Redis service is running and that the Redis service is enabled, aka that it will start on boot. What I'm going to do to run this is just run molecule verify. And what that's going to do now is instead of running a single test per host, it's going to run both of those tests. You can see here that it says collected 6 items, and that's our 2 tests times 3 hosts. And I'll come back once that's finished running. So that molecule verify task has finished running, and we now have 6 pass tests in 52 seconds. So now our tests are not only confirming that the Redis package is installed, we're also testing that the Redis service is running and that it's enabled. One thing you may have noticed is that despite not having become true on any of these tasks, it succeeded against all of our hosts. And the reason is, by default, when we're using Jeff's images or the official base images, there's only a root user that exists on the system. So by default, all of our Ansible tasks are going to be run as root. Now, this is the final improvement I'd like to make to the whole testing process, is to use a non-root user to run all of these things so we can actually test what it's like on most of the cloud providers. Unfortunately, in Jeff's images, there's only a root user available. I've forked his images and added a non-root user called Ansible so that we can test with a non-root user with Molecule. What I'm going to do is jump back into molecule.yaml and change these instances of Geerling Guy to Percy Grunwald just to use my images for this particular task. All I need to do is go into Playbook and add a vars area. In the vars, I'm going to set the Ansible user to Ansible, which is the non-root user that I've added to Jeff's images in my forks. So what I'll do now is I'll run a molecule destroy to make sure that all of the previous images are destroyed before running molecule converge again to test that Ansible will cause these tasks to fail. What I'd like to see is that when we don't have become true, that managing packages and managing services will fail. So now that destroy has finished, what I'll do is I'll run molecule converge to reapply that playbook and come back when it's done. So that playbook's finished running now, and as you can see, it's failed against all of our hosts, which is what I expected, because now what we're doing is we're using a non-root user to manage packages and services. What we need to do, because we're using a non-root user, is set become to true. And what I'll do is I'll add become to true to all of these tasks and then rerun converge to make sure that that causes them now to succeed. I've added become true. All I'll do now is I'll rerun converge to make sure that that's now successful. So that playbook's finished running now, and I can see that it succeeded against all the hosts after we add become true. So this is really good. I'm really happy with this testing setup. We're not using the root user anymore. So we have a situation that's more closely matched to cloud providers like AWS EC2 or Google Cloud Platform, where the user that you get after provisioning a new instance is a sudoer, but not a root user. All that's left to do now is just run molecule test one more time to make sure that this whole thing succeeds from start to finish. So I'm going to run molecule test. It's going to destroy the instances, spin them up again, and run all of our tests. And I'm going to come back once that's finished running. So molecule test has finished running, and I've got a big smile on my face because everything has succeeded, all the way from lint up here down to applying the role to our instances, all the way down to the verification and the final destroy. We now have a role that's been well tested against 3 different operating systems, and I hope that's demonstrated how powerful Molecule is for both development and role testing workflows.